The equipment grounding conductor, or EG, is a critical component of electrical safety. Its primary function is to provide a low impedance path for fault current back to the source. This low impedance path facilitates the operation of overcurrent protective devices, such as circuit breakers or fuses, during a ground fault condition. When a ground fault occurs, meaning an unintentional electrical connection between a hot conductor and a grounded surface or equipment enclosure, a large current flows through the equipment grounding conductor. This high current causes the overcurrent protective device to trip, quickly interrupting the circuit and minimizing the risk of electrical shock or fire. The equipment grounding conductor system is a network of interconnected conductive elements designed to ensure that all normally non-current carrying metallic parts of an electrical installation are at the same electrical potential and, more importantly, at ground potential. This equipotential bonding minimizes voltage differences between these metallic parts, reducing the likelihood of dangerous touch potentials. The path that the equipment grounding conductor provides must be continuous and have sufficiently low impedance to safely conduct fault currents. High impedance ground path can impede the flow of fault current, delaying the operation of overcurrent protective devices and increasing the potential for electrical hazards. To ensure the effectiveness of equipment grounding conductors, the National Electrical Code, or NEC, provides detailed requirements for their installation, sizing, and connection. These requirements are essential for maintaining a safe electrical system. Understanding the evolution of these requirements is crucial for electrical professionals. Before 1999, the NEC outlined the requirements for sizing equipment grounding conductors in Section 250.95. This section provided the guidelines and tables necessary to determine the appropriate size of the equipment grounding conductor based on the rating of the overcurrent protective device in the circuit. However, with the release of the 1999 NEC, these requirements were relocated to a new section, 250.122. This change was part of a broader effort to reorganize and clarify the grounding and bonding requirements within the NEC. Section 250.122 of the NEC now contains the rules for sizing equipment grounding conductors. It specifies that the size of the equipment grounding conductor must be determined based on the rating or setting of the overcurrent protective device protecting the circuit. The NEC provides tables, specifically Table 250.122, to facilitate this determination. These tables correlate the size of the overcurrent protected device with the minimum required size of the equipment grounding conductor. For example, if a circuit is protected by a 20-amp circuit breaker, Table 250.122 would specify the minimum size of the equipment grounding conductor required for that circuit. It is important to note that the table provides minimum sizes, and larger equipment grounding conductors may be required in certain situations to minimize voltage drop or provide additional safety margin. The equipment grounding conductor can be either a wire, a bus bar, or a metal raceway. When a wire is used, it can be either bare or insulated. If insulated, the insulation must be green or green with one or more yellow stripes. This color coding helps to easily identify the equipment grounding conductor and distinguish it from other conductors in the circuit. The equipment grounding conductor must be installed in the same raceway, cable, or cord as the circuit conductors. This ensures that the impedance of the ground fault path is minimized. When the circuit conductors are installed in separate raceways or cables, the equipment grounding conductor must also be installed in the same raceway or cable. There are specific rules for installing equipment grounding conductors in different types of wiring methods, such as metal raceways, non-metallic raceways, and cables. These rules are designed to ensure that the equipment grounding conductor is properly protected and connected. In metal raceways, the metal raceway itself can serve as the equipment grounding conductor, provided that it meets certain requirements for electrical continuity and impedance. In non-metallic raceways, a separate equipment grounding conductor must be installed. The equipment grounding conductor must be connected to all metal enclosures, boxes, and equipment that are likely to become energized during a ground fault. This includes motor frames, appliance housings, and other metallic parts of electrical equipment. The connections must be made using approved methods such as grounding screws, lugs, or clamps. These connections must be tight and corrosion resistant to ensure a reliable electrical connection. In addition to sizing and installation requirements, the NEC also addresses the bonding of equipment grounding conductors. Bonding is the process of connecting different metallic parts of the electrical system together to create an electrically continuous path. This equipotential bonding minimizes voltage differences between these metallic parts, reducing the likelihood of dangerous touch potentials. The equipment grounding conductor must be bonded to the building's grounding electrode system. This connection provides a path for fault current to return to the source, and it also helps to stabilize the voltage of the electrical system with respect to ground. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The equipment grounding conductor must be connected to the grounding electrode system using an approved bonding jumper. The size of the bonding jumper must be based on the size of the service entrance conductors. The NEC also addresses the use of supplemental grounding electrodes. Supplemental grounding electrodes are additional grounding electrodes that are installed to improve the effectiveness of the grounding system. These electrodes can be particularly useful in areas with high soil resistivity or in situations where the existing grounding electrode system is inadequate. Supplemental grounding electrodes must be bonded to the equipment grounding conductor and to the building's grounding electrode system. The NEC also provides specific requirements for equipment grounding conductors in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. In these locations, the equipment grounding conductor must be sized and installed to minimize the risk of ignition. The NEC requires the use of special grounding techniques in hazardous locations, such as intrinsically safe grounding and explosion-proof grounding. These techniques are designed to prevent the buildup of static electricity and to quickly dissipate any fault current that may occur. The relocation of the equipment grounding conductor requirements from 250.95 to 250.122 in the 1999 NEC was a significant change that has had a lasting impact on the electrical industry. This change was part of a broader effort to reorganize and clarify the grounding and bonding requirements within the NEC. The new section, 250.122, provides a more comprehensive and user-friendly approach to sizing equipment grounding conductors. By understanding the requirements of 250.122, electrical professionals can ensure that they are providing safe and effective grounding for electrical systems. It is important to always consult the latest edition of the NEC for the most up-to-date requirements. The NEC is revised every 3 years, and it is essential to stay informed of any changes that may affect your work. In addition to the NEC, other standards and regulations may also apply to equipment grounding conductors. These standards may include those developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be aware of all applicable standards and regulations and to follow them carefully. Proper equipment grounding conductor installation is essential for electrical safety. It helps to protect people from electrical shock, to prevent fires, and to ensure the reliable operation of electrical equipment. By following the requirements of the NEC and other applicable standards, electrical professionals can help to create safer electrical systems. Remember that the equipment grounding conductor provides a low impedance path for fault current back to the source, which facilitates the operation of overcurrent protective devices, such as circuit breakers or fuses, during a ground fault condition. This high current causes the overcurrent protective device to trip quickly, interrupting the circuit and minimizing the risk of electrical shock or fire. The equipment grounding conductor system is a network of interconnected conductive elements designed to ensure that all normally non-current carrying metallic parts of an electrical installation are at the same electrical potential and ground potential. This equipotential bonding minimizes voltage differences between these metallic parts, reducing the likelihood of dangerous touch potentials. A high impedance ground path can impede the flow of fault current, delaying the operation of overcurrent protective devices and increasing the potential for electrical hazards. Understanding the evolution of these requirements is crucial for electrical professionals, and that before 1999, the NEC outlined the requirements for sizing equipment grounding conductors in section 250.95, but with the release of the 1999 NEC, these requirements were relocated to a new section, 250.122.